Hello, everyone. I was going to say good morning, but it's officially good afternoon, at least here in Central Time. Welcome to today's webinar, a masterclass in maximizing metal sector revenues through energy strategy. I'm Shannon Wetzel, managing editor of Modern Casting Magazine, and I'll be introducing you to today's speakers and helping out with a Q&A at the end of this session. We have a fantastic webinar for everyone with two speakers from Grid Beyond. Before I introduce them, I want to go over a couple of housekeeping items. First, this webinar will be recorded and made available to today's attendees. You'll receive an email with a link to the recording within a week after the webinar. Second, the presenters will be answering questions at the end of the session. You may type your questions in at any time during the webinar in the question box in your control panel there. And now let me introduce our speakers, Wayne Muncaster and Aidan Downs. Wayne is a regular industry speaker and advocate for enhanced energy services and demand response. He's also VP for North America at Grid Beyond. With over 20 years experience in the energy sector, Wayne has seen the energy landscape change significantly and is ideally placed to provide advice and education on this complex market. His invaluable knowledge and expertise have secured him a spot as one of the energy industry's authoritative voices. Aidan is a highly qualified electrics and engineering expert and joined Grid Beyond after spending several years delivering automated solutions across a number of different sectors. Since joining Grid Beyond, Aidan has led the customer-facing technical team in developing proposals and delivering technical projects across several international markets. His understanding of industry-specific opportunities and challenges is unrivaled. So thank you all for joining us, and Wayne, I'll hand it over to you.
Thank you, Shannon. Sorry for interrupting you halfway through my wonderful introduction there. Thank you very much, and welcome everybody. Good afternoon, good morning for those of you not yet into the afternoon. And welcome, as Shannon says, it's from Europe and the US. And some of the innovative things that we do with various different types of metals businesses. We're going to show you some case studies in terms of how we do that. And we've kind of split the webinar presentation into two. So I'm going to do most of the talking for the first half of the presentation, sort of introduce you into what we do and the types of services we do, and then Aidan will pick things up toward the end and do the much more complicated engineering section in terms of how it actually works and how we integrate some of the assets on metal site into the various different energy strategies that we carry out. But before we begin, a little bit about who we are and why we talk to commercial industrial businesses around the world. Grid Beyond are a global leader in intelligent energy technology. You can see that we are an award-winning energy technology company, awards from both Europe and the US. What we do is we work with commercial industrial businesses across multiple sectors, one of the core sectors of which is the metals industry. We work with those clients, those end users, to partner with them to design ways that they can flex their energy consumption, their demand, to participate in traditional demand services, ancillary services within those markets. For example, ERCOT in Texas, PJM in Pennsylvania, but also the ways that they can work with their suppliers, with their power suppliers, to benefit from greater access, more controlled access into the wholesale energy markets, the way that they can use the data that our platform and our systems provide to understand their energy usage, and that has particularly interesting applications within furnace environments, for example, which Aidan will touch upon in the second half. And we wrap all of that up in ways ultimately of earning revenue in the energy markets and saving money on energy bills for those metal companies. So I'm very proud of our heritage. The metal sector is something that we've been working in for over 10 years now. In Europe, we have some very big names and some much smaller names within that, but we'll talk about some of those case studies later on. But we want to share with you exactly what we do. We're very proud of our relationship with the AFS. We joined the Foundry Society earlier this year. This is the first of our webinars with them, but we definitely hope it won't be the last. part of our approach to these sectors, to industry, is to work with the industry bodies, work with the educators within those industries. We're members of over 20 different industry bodies across America and Europe, and we see education and getting the message out there as a very big part of what we do. We have our own Grid Beyond Academy, which contains other webinars and briefings, etc., and case studies and materials to help you understand different parts of the market, etc. And as I said, we're very proud to work with industry bodies like the AFS in getting the message out there that there is a different way of managing your energy demand and participating in markets and ultimately lowering your net spend. So Shannon gave a very lovely introduction to Aidan and I'll let Aidan introduce himself in 30 seconds time. But for me, Wayne Lancaster, VP of North America, I've been in the energy markets for nearly 25 years now. Started in energy supply with Centrica, who were the owners of Direct Energy in North America until earlier this year. 12 years with those into deregulation of the UK energy markets for gas and power, and then moved into energy technologies in around 2000 and 2005. Spent the last 15 years working with different types of energy solutions, all focused on commercial industrial businesses and effectively better integrating them into the energy economy. Aidan, do you want to just introduce yourself briefly?
Yep, thanks, Wayne. So my background, I started out as an electrician in the aggregate industry. In that apprenticeship and then electrical career, I got into automation. I then qualified as an automation engineer or an electrical engineer that focused on automation and joined Rockwell Automation. I spent 6 years as a field engineer and then went and became a project engineer, basically delivering automated solutions in every possible industry. Across my time with them, I joined Grid Beyond 3 years ago, and my role with Grid Beyond is leading our auditing team to proposals to find out the flexibility and opportunities on sites and putting them into proposals. And then once customers sign up with us, delivering the installation and bringing those sites live. Back to you, Wayne.
Excellent, thank you, Aidan. And as I said, I'll give you a kind of top-down introduction in terms of the markets we operate, what our business basically does, and then Aidan will talk to you about the really interesting stuff and the detail of some of the metals clients and the actual assets that we integrate into the market in a few slides' time. So, as a brief introduction, and apologies for those who have a great understanding of the electricity markets and how they operate, but for those that don't, our energy systems are transitioning, they're changing, and they're changing fairly rapidly in most parts of the world, slower in others, obviously, but generally across the world, those systems are changing incredibly rapidly. So in most parts of the world, we are moving from a traditional system built out of the Industrial Revolution, revolutions as they occurred across the globe, where we would have very, very large thermal power plants, generally powered by coal or oil or more recently gas, shipping power over very large distances through very expensive and very long transmission and distribution networks, pylons that you see in the fields and the pipes under the ground into homes and businesses around the world. And that one-way street of power flowing one way, and then ostensibly people paying their invoices and their bills and cash flowing back up the other way, operated for 70, 80 years from the kind of European and US perspective without much interruption. The transition that's occurring today, whether you believe it's driven by climate change, by policy, or by economics, really doesn't matter. The facts are there that the system is changing. And the system is changing in a number of ways. So we're seeing new types of generation technology coming onto the system. So obviously predominantly wind turbines and solar PV at large scale at the moment. We are seeing in most parts of the developed world now an increasing proliferation of battery energy storage. Again, maybe faster in some parts of the world than others, definitely faster in some parts of the US than others. But we're seeing those kinds of assets come onto the system alongside thermal generation, but we're also seeing a decreased volume of that thermal generation, particularly from coal and oil. Gas is maintaining its position and increasing in some parts of the world, but generally the older thermal fuel types are being decommissioned as those plants come to an end and replaced by different technologies. And then on the other end of the spectrum, those traditional pure consumers of energy are starting to become generators of energy as well, whether that's in your home. You might have solar PV panels on the roof. In some instances, you might have EV charging, you might have battery storage in your garage. But that's becoming much more widespread, particularly around the developed world, obviously. In commercial and industrial businesses, many more of those businesses taking self-generation much more seriously, so starting to invest in their own assets, whether that's solar PV, whether that's gas generation, whether that's even wind turbines in some instances. In some parts of the world as well, putting battery energy storage into that mix. So they're creating their own virtual power plants within their sites. And then obviously we have smaller scale distributed renewable generation as well. So suddenly that fairly simple, easy to manage, easy to understand one-way system we had is becoming a very complex cyclical system where consumers are becoming generators, generators are becoming much more dispersed around the system, and the traditional transmission and distribution networks that we've always had suddenly don't quite fit the bill. And that means that the system operators, the people like PJM and Eurac, the power suppliers themselves, have to change. And that energy transition is basically what drives our business, and the reason that organisations like Grid Beyond exist to start to facilitate that energy transition. So you will have seen, or you may have seen, people within the energy markets talk about the 3Ds. So decarbonisation is that transition from traditional fossil fuel types, coal, oil, gas, into renewables. And as I said, whether you're passionate about driving that through policy because of environmental concerns, or whether you're just interested in the economics of the cost of the reducing cost of renewables versus the increasing cost of getting things out of the ground and burning them in fossil fuels, doesn't really matter. The economics are the same from both sides of the fence. Decentralization is, as I've said, to people becoming much more interested in their own generation, whether that's to reduce their costs of energy, generate their own heat and power, or whether that's because of issues and reliability issues on the network. Perhaps seeing some of the types of issues that ultimately this transition drives, which is brownouts, blackouts, if we don't get it right. So that decentralization of energy supply is becoming much more prolific, and again, residential homes suddenly being able to generate their own power, and potentially even ship that back to grid at times. All of those require much more of the third D, which is digitalization. And that's basically having the technology that can make those assets talk to each other, that can give visibility of what's happening within that system, and ultimately can deliver the same element of controllability to that system as a traditional system operator might have had just talking to a generator station. So that's where we operate. We sit in the middle of that, and we'll carry on that theme as we talk through the webinar, but we sit in the middle of that, and our technology, our platform is designed to enable those assets to integrate together, renewable assets, load-bearing assets, storage assets, and to provide visibility to the people that own them and the people that need to be able to see them and or control them at different times. So we'll spend too much time on this, but we're seeing that as part of that transition, the more typical energy market change. So rather than, we've already moved from a period in time where you just have a fixed price for electricity. You sign a contract at 7 cents, 8 cents, 11 cents, or even 3.5 cents if you live in Texas for the next 3 years, 5 years, and that's what you pay. Much more proliferation of the kind of block and index contracts where you fix an element of your consumption and then flex the rest depending on pricing market. And the ultimate extension of that, and already seeing it extensively in Texas and Europe, is the wholesale market access product, where you're effectively tailoring your consumption depending on the pricing market. So you're using more power, potentially even storing power when prices are really low, overnight off peak, and then you're reducing your power consumption as much as possible, even by shifting production at times, to make sure that you're missing the times when it's most costly market. So that kind of greater interactivity in the energy markets is great. It's great for everybody in terms of managing the system going forward. It extends the traditional concept of demand response as just either peak avoidance or ancillary services, capacity market type participation. And it also provides benefits from the data that we can collect from the systems that are required. So our platform, for example, installed on a metal site, collects huge amounts of data and information on the efficacy of those assets, the efficiency of those assets, how they're operating, any kind of degradation in performance. There's all manner of analysis that can be done on melt times, melt durations, etc. For example, in furnace site, in metals. But we can take that energy data and with the clients, either feed it back for them to do their analysis themselves or help them do the analysis. And ultimately, in terms of investment in assets and looking at either extending their self-generation, installing generation assets, installing batteries, we can help them with the funding model and do help them with the funding model and installing those types of assets inside. All of that wrapped up in a blanket of helping you reduce your net energy spend. In other words, adding either revenue onto the bottom line from participating in energy programs, or simply reducing your peak charges on your bills to provide the same kind of benefits. So just a little bit about the opportunities in the markets that I've touched upon briefly already. So demand response services can do all manner of things, but ostensibly most demand response services as they stand today are designed to help balance the electricity system. And again, for those engineers out there, for those with an understanding of the electrical markets, I apologise now. This is going to seem fairly dumbed down, but it is a kind of fundamental aspect of what we do. So the way that the electricity system is measured in terms of its balance is a perfect balance of the right amount of power generated, supplied, versus the exact amount of power consumed. Means that in the US terms, to do that, the system will be sat at a very nice 60 hertz. It's never the case. It passes through 60 hertz on a very regular basis, but effectively frequency on the system bounces up and down every second and down to the millisecond, and that's because maintaining that perfect balance of the amount of power generated versus the amount of power consumed is obviously incredibly difficult. Switches go on and off, load goes up and down, generators come on and off stream, the wind blows and stops blowing, the sun shines and clouds come over. So maintaining that balance is a constant activity within a system operator. And that system operator requires tools to help them do that. So traditional tools would have been what are called post-fault programs. So in other words, they're aimed at correcting an event, an occurrence when it becomes a problem. So generally on all systems, if there's more than a 0.3 hertz deviation from that 60 hertz equilibrium, then it's a big warning sign that things are about to happen. If that dropped to 0.5 hertz, for example, then parts of the network would see power go off, and they'd see blackouts, potential brownouts, and there'd be issues on the network. So those traditional post-fault schemes are reactive to a changing frequency on the system, a defined point in frequency deviation, and that can trigger some kind of response. Generally automatic, but it's designed to reverse the fault and bring frequency back towards that 60 hertz. Increasingly, as we put more and more renewable generation on the system, we get much more occurrences of deviations in frequency, and we get a much faster change in rates of frequency. So we get the rate of change of frequency, or rock-off, for example, becomes a much bigger issue when we have intermittent generation like wind and solar. And that's simply because the changes in the generation profiles of those assets can happen much more quickly. So as I said, wind blows, slows down, changes, cloud cover comes over a huge, 10, 20, 30 megawatts or bigger solar farm, then that can create very fast drop-offs in supply, and that creates very quick frequency deviation. So increasingly system operators require faster acting services. In other words, they require services that can keep frequency close to 60 hertz without it having to drop off much lower. And those fast acting services are where we come in. So we control assets generally in seconds rather than minutes or even hours in some of those traditional services. So we'll come on to that in the second half through Aidan when we talk about the technology. But those services historically would have been generally the preserver and the generators, but in demand response, system operator absolutely requires more and more people to become involved. So as I said, as that energy economy expands, becomes more decentralized and distributed, then many more players are required to help deliver these changes to the system to keep it on track. And that's ostensibly what demand response does. It engages people like you, commercial industrial businesses in many sectors, but in the metal sector engages people like you to get involved in the market, help the system operator balance the system, and get recompensed for doing so. So we've touched upon this, and I won't spend too much time on that, just on this, but just as some background, this is a view of Texas as it stands, and some of the kinds of changes that we're seeing on the system. So we've got a system that's changing incredibly rapidly. So over the last 10 years, you see there we've seen a 20% plus swing from coal to wind. We've seen fairly steady amounts of gas and nuclear on there. And we're just starting to see the proliferation of solar. What's interesting for us in the Texas market is that that's not policy driven. There have been elements of tax subsidies, etc., for siting certain types of generation, but generally it's been the market driven purely by the economics. There's a lot of sunshine, a lot of wind in Texas, a lot of land in Texas, so it lends itself very well to renewable technology. And the levelized cost of energy of renewables, the way that one type of energy generation is measured against another, is very favorable for renewables, particularly in Texas, where the cost of connection may be relatively low. So again, for an unsubsidized market, Texas has more than twice the volume of wind as the next highest state in the US, more wind in Texas than any other state by a factor of more than 2. And that's historical, and it's not changing anytime soon. So if we look at the interconnection queues, in other words, these are the new generation assets that are in the pipeline that are going to come on stream over the next 1 to 5 years, then you look back at 2014 and it was a market dominated by gas and the very beginnings of those large-scale wind projects that are now firmly embedded in the Eurac market, to one which is dominated by solar. And then the next two are wind and batteries, and you can see the level of gas there is basically just topping up the thermal plant, which is being decommissioned. So we're just replacing like for like. So the growth is all coming from renewables, and that drives the kind of changes that I talked about earlier. Okay, so at this point, I'm going to stop talking about generalisms and hand over to Aidan and let him talk you through some of the interesting detail in terms of what we do in metal sites. Aidan.
Thanks, Wayne. Okay, so I suppose my role is to look at flexible assets on site and the processes that those assets are involved in. So I suppose in the metal industry, on average, we reckon there's potentially 60% flexibility on any metal site. Some sites it could be 90%, some sites it might be 10, 20%. 20%. It all depends on, I suppose, what you're making and what your process is. So the common assets that we have found in your industry across the number of sites and customers that we've live in these services, I suppose, mainly it's furnaces, induction furnaces, arc furnaces, whether they're melting or whether they're just holding temperatures, extraction fans, and some air compressors as well would be, I suppose, other assets, but primarily it is the furnaces that we find flexibility in. So what we would do is we would go to site, we would look at these furnaces, how we would monitor them, how we would control them, how we would externally communicate to these assets, whether it's extracting the monitoring data to our platform and sending control signals to turn these assets off when the grid requires it. What this does is it allows you to enter the grid services. It gives you new revenue two main things. It gives you revenue, but it also gives you a large quantity of savings by avoiding peak tariffs. Okay, so I suppose our unique selling point is we understand assets and we understand processes. So we're in a lot of different industries, and we have a lot of sites and customers across those different industries. What we do is we look at the assets. We look at big energy using assets that can shed load, and we bring them into these services. So what is important for you in your process? What are the critical parameters? In your industry, I suppose temperature is key. The time of your melt for arc furnaces, first 5-10 minutes, you're stabilizing your arc furnace. If we shut you down during that, it causes it could damage your end product. It affects your process. So it's understanding what's important to you and trying to work with you to find flexibility around that. So by looking at your, I suppose, important critical parameters, we will then know what the most suitable service is for you and your particular site. So we're across the metal industry entirely. We're involved in casting, copper, steel. We have customers that make brake discs, unibar cast iron, scrap metal. Eurac Pool, UCB, Outokumpu have a massive arc furnace. Eurac Pool have, I think, 2 furnaces. UCB have 2 furnaces, both of them 4 megawatts each. So they're big energy using assets. And I suppose we've gone to site, we've audited these sites, we've come back with proposals, and the customers signed a dotted line, and we've had them live in schemes, particularly UCB, Eurac Pool for years. Outokumpu signed up this year and have been live since February. So we've huge industry experience. I think this slide, it shows 5 sites and it shows a huge amount of megawatts, but we have another 20 sites that could easily be here as well. If you want to skip on, Wayne.
Yeah, sure.
Okay, so Eurac, what we have here on this site is a hybrid solution. So we've actually put a battery on the ground on this site. So we've gone to the site, we've audited its load, we've looked at their half-hourly data, and we've seen that this site was suitable for a 1.6 megawatt battery. So with a partner, we've installed that battery, and that battery certainly it covers the site during peak tariffs. So if you think of your 4 CPs, when you're called to turn down for this service, the battery would then provide energy for your site. So you're not effectively losing production, your battery is backing it up. This site has also got 2 furnaces, both of them 4 megawatts. They're in RRS UF4 type services, so a 1-second shutdown. This is done through the PLC, and all the time we're monitoring their critical parameters, and it's generating that sort of revenue there, 251,000 in revenue and 65,000 in savings from what we do with them, from the services we allow them enter. The next case study. Sorry?
I think it's fair to say, Aidan, we on those furnaces, rather than a kind of complete traditional curtailment or shutdown, as we might understand it in the US, we're looking at effectively turning those furnaces down to a hold pattern. So we're not turning them off completely within seconds. We're kind of bringing them down to a hold. Is that right?
That's correct. Yeah, that's correct. Yeah. Again, every site's different. These furnaces have the capability to be turned down instantaneously. Other furnaces need to be shut off. So yeah, that's what's happening on this site. So Outokumpu on this site, we're controlling an electric arc furnace, and we're controlling a DC furnace. This is all done through a PLC, and it's delivering a 1-second response. Again, it's a 0 capex project. We had it live within just over 2 months. So that's from initial engagement, signed proposal, and then detailed conversations with their control engineers, and then going to site and installing and implementing it. So yeah, it's an arc furnace that we have live in an RRS UFR type of service. So United Cast Bar is another I suppose really good customer of ours. Again, it's a hybrid solution. We've got a battery on the site that is both delivering grid services and providing resilience to the site. This particular site has two 7-megawatt furnaces. They rely on us heavily for the 4CP type services, so we're generating huge savings for them as well. And they're also in the RRS UFR type services. We have a great relationship with them, and they're constantly on the phone to our commercial people. What more can we do for them? So that's the third case study. Back to you, Wayne, I think.
Yeah, thanks, Aidan. There's a couple of slides here that I'll do, and then I'll hand back to Aidan to talk about some examples of with schematics about what we do in furnaces, etc. But as Aidan said, we work with arc furnaces, induction furnaces. We work with annealers. We work with some of the peripheral processes around those. We work with generation on these sites. We've actually physically installed batteries on a couple of these sites, UCB and Eurac being two of them. So there's any number of initiatives that we undertake with these metal businesses, but all of them have in common the sophistication around our platform that holds things together. So as I said, we're a technology company. I think it sometimes goes without being said by us, but it should always be said that effectively what we're doing is we're installing our platform, and we do install our platform on all the sites that we integrate into various different types of programs. Our engineering team, led by Aidan, will do the design study. So they'll audit the sites, they'll talk to your engineers, they'll come back with an interim design that will be thrown around by a room full of engineers over a couple of hours to get it to the point where everybody understands it and believes in it. And then it's that design which is built into our system. But effectively, the platform that we then subsequently install in site looks something like this from a schematic perspective. So it is capable of taking multiple inputs, either internally or externally. So externally, very simply, that might be market price for power. That might be grid frequency from an on-site frequency relay, knowing when we need to trip. It might be external weather factors. It could be anything that we put into that model to help us understand what the site needs to do at a particular time. Most importantly, in terms of inputs, is going to be a number of inputs from your site. So we take on the traditional inputs like metering, so we always understand the consumption of your assets, or asset, depending on what we're controlling. So for example, for your furnace, we will have second-by-second data on the consumption profile of that furnace or furnaces, and any other peripheral assets that we're metering as well. We will take in whatever operational constraints we need to take in. We can also use those operational constraints to create alerts. So for example, in most of the metals plants that we operate, we will operate entirely within their existing operational parameters, but input back into their existing control systems to understand when and when we can and when we can't make any kind of interruption to that process. Could be as simple as where they are in the process based on the consumption of the furnace. But all of those constraints we'll take in, and then if we do create an event, in other words, if we do make an interruption, then we will generate alerts and alarms. And those alerts and alarms can be the traditional type that we do in any other sector, like emails and text messages, etc., to any number of personnel that need to know what's going on. But in metal sites, we'd also do audible and visual alerts and alarms. So we'd have klaxons, we'd have flashing lights, so that the furnace operators would know that there isn't a fault on the system, that nothing's happening which is untoward, that effectively that sudden drop in power or temperature that starts to occur is the fact that there is an event on the system and no call or PGM have called that asset into operation. So there are any number of ways that we can and do make it safe. Health and safety is always our primary concern within metal sites in particular. But once all of that is done, the output of that, as I said, is a bunch of control signals that go into your assets. Your control board, you get Viewpoint, which is our dashboard that can show you historical information around consumption, around revenues earned, participation in scheme, etc. It can also show you anything to do with the alerts and the operational sensors and constraints that we're putting through. So that can be built into the platform. And then ultimately that platform is what drives your participation in program. So in summary, you have your on-site assets integrated into our platform. Talk briefly about the on-site platform, which is kind of the local brains of the information of the organization. Then you have viewpoints, which is the window into what's happening on your site, what has happened historically, how much you've earned, what those assets are doing at any particular point in time. Viewpoint can either be your energy management system if you want to pull that data through, or it can feed into your energy management system if you have one already. So in other words, we can take the data that we pull and we can add it into your existing EMS energy management system. And then the bit that I haven't touched, I guess, is Centrepoint, and it's through Centrepoint, which is our cloud-based engine, which is where all the sophistication comes in terms of external inputs and reporting, etc., and feeding back through to your system. So we work on creating something which is continually learning. So the system that we first install in your site will be as best as we can get it between our engineers and Aidan and your engineering staff in terms of the assumptions on what we can do and when we can do it, how quickly the asset can respond, the recovery times that it requires, etc., the time to run back up. All of that, we will make educated assumptions and build them into the system with your engineers. As the system develops, as it goes on, it starts to learn how your site operates. So all that data it's collecting, all that understanding about your site, about your assets, about your processes, what happens if, what happens when, could be the impact of ambient and external temperatures on a cold store. It could be the impact on production and output on a furnace plant. All of that data creates an increasingly sophisticated model of your plants and your sites, and enables us to get increasingly sophisticated in both the types of programs that we can deliver for you, but also the efficiency of those programs and the efficiency of those systems. So imagine, for example, peak avoidance, 4CP, or global adjustment avoidance, or whatever your particular local scheme is called, getting a really in-depth understanding of your consumption profiles, your production patterns, enables us to perhaps move from having to dispatch you 20 hours of the summer to avoid those 4 peaks in Texas, to getting something which is might come down to as low as 12 or 13 hours, all of which reduces your cost to participate and increases your net savings. So that sophistication is important, and it's not just a one and done system. We contract with clients for 3 to 4 years, and we work with them as constantly as they'll allow us to develop these systems and increase the sophistication. Aidan, back to you on the interesting stuff.
Thanks, Wayne. So arc furnaces, I suppose, can they participate in fast static schemes? So there are challenges with getting arc furnaces into these schemes, and what we have done is we have worked with on-site engineers and third-party control parties to deliver a solution. So the things that are important to us and to the grid is the frequency trigger. So what the grid requires is for you to shed your load within 1 second when the frequency dips to a certain trigger. We then require high-speed monitoring and high-speed control. 1, to capture the load shedding, and then 2, to shed the load within 1 second. So I suppose our platform has this high-speed, I suppose, monitoring. And it's able to, I suppose, send these signals in milliseconds to deliver this in time. What happens is we could be going through a PLC that's controlling a full site, and there might be a 3 or 4 second delay. Or there could be a PLC talking to a different PLC that talks to the arc furnace. So it's looking at the current control on site, and if it isn't good enough, coming up with a solution to deliver this 1 second response. So the way we do that is, I suppose, we remove bottlenecks, which is usually the PLC, the control that's already there. Find out the fastest way to communicate with the actual arc furnace itself, rather than going onto a BMS or a DCS type system that can be slow. So Wayne, if you just want to go to the next slide. Okay, so I suppose this is what we have done. We found on certain sites we're talking our controllers on a communications panel, and then it's going to a site-wide PLC, and then a signal could be going to an individual arc furnace PLC, and then the arc furnace PLC sends a signal to lift the hydraulics. So all that takes time, and that time adds up, and all of a sudden we're not delivering the load shedding within 1 second. So I suppose what we try and do is we talk directly to the individual arc furnace PLC. The way we have delivered these arc furnaces is by simulating a controlled stop. So if you can imagine a heat stop signal, or a ladle car limit switch, or a low flow, we integrate our signal to simulate one of these stop signals. This raises the electrodes immediately and drops the load immediately. Then the VCB trips. But from our monitoring, we see that load shed in less than a second. Another option would be, a critical alarm, such as, lost cooling water. By us sending an input into your arc furnace PLC, and by the third-party control taking that input and triggering a heat stop signal or a lost cooling water signal, this all stops the arc furnace within 1 second. We have looked at other options, transformer tapping. We found them not to be fast enough. Not many sites out there have thyristor controlled transformers controlling their arc furnaces, but that would certainly deliver it. But again, it's going to site, it's seeing what control solution is there, and trying to use that to deliver the arc furnace into grid schemes. Wayne, I think that's it on that one, if you want to move on. Okay, so this is an example shutdown. So this is data that we have gathered from, I suppose, Outokumpu's arc furnace. You can see it's 0.9 second. So we have a piece of equipment that triggers a shutdown, but also monitors the shutdown as well. So from that immediate trigger point, it starts counting, and it measures the load dropping, I suppose, in milliseconds. So as you can see, in 0.9 seconds, with a 40 megawatt arc furnace drop its load using the control solution I've just discussed. If you want to go on again, Wayne. Okay, so I suppose we're very aware arc furnaces have kind of a melting profile, if you will. So they come on, and they come on hard, driving the temperature of the substance down. Then they might go off, and they come back on, and they go off, and they come back on as your arc furnaces works to get your substance to that ideal temperature. So there can be white space, there can be, as in it mightn't be available 50% of the time, it might be available 30-40% of the time. And what we do is we aggregate, I suppose, that particular furnace with another furnace. On Outokumpu's site, they've got a DC furnace that is on nearly constantly, and that way we always have some sort of load to deliver to the grid. So we, I suppose, as a company, aggregate load across a site to deliver a kind of a steady load to the grid if you are called for an event. If you want to go on again, Wayne. Okay, so look, it's the furnace process. What are you making on site? What's important? Are you 24-hour casting? Is your melting furnaces melting the metal, getting it to, I suppose, sorry, melting the substance? Is it getting it to a certain temperature? Is your holding furnace holding it until your casters are ready for another pour to go into it again? So it's, I suppose it's really, our unique selling point is understanding what your individual site does and finding flexibility, going through scenarios with you. What if this happened? What if that happened? Understanding the critical points in your melt. If we were to turn you off at this particular time, would that cause the product to be damaged? Would you have to throw it out? So it's understanding all of that sort of stuff and finding flexibility and buffer to deliver a furnace or maybe all your furnaces into these grid schemes. We're constantly monitoring your critical parameters, temperatures, and it's not an exact science. It's back and forward with us and you. You might have a very tight window of temperature, very tight temperature control. For example, 80 to 82 degrees. If it's outside those degree thresholds, you're not available to us. Well, that mightn't work because you might never be available then. So it's finding that sweet spot where we don't hurt your process and we have you available for as much as possible for grid schemes. If you want to go on again, Wayne.
Yeah, sure. I think we're just about done then.
Okay. Yeah. So back to you.
Excellent. Okay. So yeah, as you can see, it's not just a one-size-fits-all drop and walk away type transaction when we engage with our clients. It's something that we take our time. We understand your business. Aidan's team spend a heck of a lot of their time understanding your business, designing a system which will fit and will fit safely and without impact on your operations. They work with you and your engineers, but they also work with any third-party engineers. So they work with your furnace contractors, they might work with your controls engineers, with your controls contractor to understand exactly how the system will work. That could take a couple of weeks, or it could take a couple of months, depending on the level of engagement that we get and the speed of engagement that we get from various parties. But it is all managed by us, project managed by us, and ostensibly we just look for you to provide us with an hour or two of your time to review the outputs as we go along and to tell us whether we're doing things correctly that you like or we need to make some changes. So we try to minimize the input from our clients in terms of time, but maximize their review and their sign off on anything that we put together. And ultimately, at the end of the day, that then delivers you a business case, a proposal, with zero commitment, financial commitment from you, other than that couple of hours of engineering time, and you can then decide whether it's something you want to do. The collaboration extends to obviously working with grid operators, system operators, understanding their needs and their constraints, not just the programs that are out there today, but the programs that are coming through the pipeline. We get involved in a heck of a lot of research and development programs with system operators looking at future services, what we might be able to bring from commercial industrial load. As I said, we're one of the global innovators in this, and our understanding of what commercial industrial businesses can do for electricity markets is probably unparalleled in terms of the detailed understanding and operational understanding. So we bring that to system operators and grid operators, help them to understand it and how that might fit with their plan. Battery providers, gas generator installers, we work with the likes of Cummins and Caterpillar. We work on gas. We work with the likes of Tesla and NEC on batteries, amongst many, many others. But working with those battery providers, their installers, their developers, the financiers behind those programs to understand projects and where they might fit, and also your electricity supplier and LSEs. We're partners with 6 global utilities. Global, they have operations in both Europe and the US, rather than any word further, but we work with those very, very large power suppliers to understand their needs and their requirements, how they see the market changing. It can be investing in some of those assets I've already talked about, like generators or batteries, or it could be providing access to wholesale markets to benefit their clients. So we work with all of those, and as I've said, we sit in the middle of that as a business and pull that collaboration together to put some of the exciting projects into market that you see. And we also sit in the middle of your site and groups of sites and bring them together through our technology to participate in markets. So collaboration is critical and it's key to what we do, and we're very proud of it. So hopefully there's been at least elements of interest for you over the last 50 minutes or so. And yeah, Aidan and I and the team here will be delighted to take any questions you might have. Shannon, over to you.
Thank you very much. It was a great presentation. Obviously, energy is a big part of Foundry costs, so anything that can help control that would be really important. So right now it would be a time to put in your questions, and we have about 10 minutes or so to answer them, and then we'll log off. So let's start off with one. Have you ever had any issues with turning off furnaces so quickly?
Aidan, do you want me to take that one?
Yeah, the short answer I think is no, but if you want to.
Yeah, no, the answer is no. I think we had a very similar question from the refrigeration industry yesterday. I know we did another webinar for food business yesterday. It's a really good question, and it's perhaps the most common of questions. You know, what happens if? So we're proud to say no, never with a furnace. Much greater implications of having issues with furnaces and refrigeration systems, obviously. But no, we take a great deal of care. So you know, we did, as I said, we design a system. We design a system ultimately which is probably oversafe, in that will understate what the system can do, if anything, for implementation. If there are 2 or 3 elements and one of them is really simple and safe, and the other 2 need some more work, we'll just do phase 1, and then perhaps move on to the other phases later down the line. But no, we'll always take ultimate care in designing the system safely at the very beginning, be very prudent, and then once that design is done, we come along and we install. We install and we test. Sometimes we test the theory of what we're doing before we install. So Aidan would have lots of experience of going to a client site and simulating a sudden drop in power that we would do through our control, through our system, to make sure we can see what happened in the control environment. So yeah, where the client demands it, we will test it first. We will always test it once it's in, and then we'll test it again, and then we'll test it again, and then we're all sure it can do what it should be doing, we'll put it into market. But as I've said, it's a system that isn't dumb. It's very clever. It monitors consumption. It monitors what's going on the system. So often, if there are any problems, even unrelated problems to our system, they're seen and they're tracked and they're managed very early. But we've had 0 issues with our system in any of the metal sites we've done.
Yeah, the key thing there, Wayne, is we use our customers' control. We sit on top of their control. Yeah. So, you know, as long as their control works and it's tested and they're happy, there's never an issue, and there hasn't been.
Yeah. Okay. So Aidan's team would work with your PLC SCADA controls engineers, in-house or external, and would get them to change the software within your existing control system to either accept or reject our signal. So in other words, if our system was trying to do something that your system didn't like, then it would simply reject our signal and nothing would happen. So that's ultimately your safety net for anything that you do.
Okay. Someone had a question just clarifying the assessment that you perform. So the assessment is free, and then you'll provide guidance on the services that could be provided based on the results from that assessment. Is that fair to say? Okay.
Yeah, perfect. So yeah, we'll do some sort of desktop analysis of your consumption profile. So we're looking for seasonality. We're looking for, you know, your 3-day shift, a 4-day shift, 4-day week, a 7-day. You have 2 shifts a day, 3 shifts a day. So we're just looking for simple things within your consumption profile from your install data. Then you'll get a phone call from somebody in Aidan's team to one of your engineers and just ask you some hopefully very intelligent questions about the assets that you've got, how they're used, and how they fit with the kind of consumption pattern we've already seen. And then we take that away, and then we come back to you with a proposal based on, this is your site consumption, this is the flexibility we think we can get from the assets you told us about, and these are the programs that we think we can fit you in and what you would make. And that indicative proposal, that interim proposal, is then something that we pass backwards and forwards as many times as necessary until we get with a final design. And at that point, we're looking at sort of the install arrangements. Where's our panel going to go? What kind of cabling runs do we have? And it's at that point that we then sit down and say, are we going to do this? Is this something you want to do? And we start talking about contracts. But up until that point, zero financial input from any of our potential clients.
Cool. We have 3 more questions here, so I'm going to try to make sure we get these in
I'll be quick.
within the next 5 minutes. Do you have experience with reducing power consumption versus turning off a variable frequency coreless induction melt furnace to respond to strategy signals?
Yeah, I mean, if I understand the question, you're talking about, I suppose, reducing your site's power consumption by turning off an induction melt furnace.
Right.
So yes, we have a lot of experience.
Okay.
I'm not sure if I've answered that. A lot of the furnaces that we control out there are that type of furnace. However, if I haven't answered your question, please come back with another question. So
I think they're specifically looking at coreless induction furnace.
A coreless induction furnace.
Yeah.
Yes, we have experience with those. Yeah.
So induction furnaces were the first sites that we did in the UK in particular, and now across Europe. But yeah, and induction furnaces was probably maybe even 7 or 8 years in advance of our work with electric arc furnaces. We had to do much more design work on understanding arc furnaces and how to control them. As Aidan said, a lot of them in the UK in particular are controlled through transformer tap setting, and getting into React quickly was really difficult. So they'd operate in much simpler programs or not in programs at all. So induction furnaces are meat and drink. We work with induction furnaces in both metals and glass. So we've got people like Ardagh Glass and OI, Cornings OI that we work with. So yeah, most of our metal sites are induction furnaces. In terms of numbers of sites, most of our megawatts are arc furnaces. So those things are much bigger. And we've also got annealers and other aspects of metals as well.
What about reducing the power level versus turning it off?
Yes, we do that on a lot of different sites. So it depends on the type of control of the furnace itself. Can it reduce power in 1 second? Is it transformers? Is it thyristor control transformer? It all depends on the type of control of that furnace. Some furnaces, they don't have that control. They're older furnaces. You might have to turn them off using a circuit breaker. Other furnaces, they're newer, more modern furnaces that have that ability to reduce control in 1 second rather than turn it off by a breaker.
Yeah, and I think again, generally in the early, certainly when I joined the business 4.5 years ago, a lot of the induction furnaces were turned down to a kind of 30 or 35% hold. So we'd have enough power in there to keep the product molten, and then we would hold that for 30 minutes, maybe even 45, 50 minutes sometimes. But generally that's what we would do. So it wouldn't be a turn off an induction furnace. It would be reduce it to a whole pattern of generally 30 to 35% power.
So what about a facility that maybe is already highly optimized with on-site generation? They've got peak, off-peak load scheduling and PLC day load reduction, plus pricing based on decision making. Is there more that they can be doing with Grid Beyond?
Congratulations, first and foremost. It sounds like you're ahead of the curve, whoever's come up with that. So I'd love to meet you, whoever it is. But generally, it's perhaps we're looking at more sophisticated type systems where we're getting into the kind of virtual power plant. So we're making intelligent decisions on maybe you're already making those intelligent decisions, but we're making intelligent decisions on grid supply versus generation, etc. And so yeah, getting more into the virtual power plant type concepts rather than just simple on or off and put it into program. But yes, we get involved in that. You looked at Eurac there, so we worked with Eurac supplier, a company called Haven Power at the time in the UK. We worked with ESB, or the Irish utility, who put the 1.6 megawatt battery into that site. And effectively what we were doing is between the power supplier, National Grid, who were the system operator, Eurac and ourselves, is we were we were making very informed decisions about sort of where that power was coming from, the level of use of that of the battery, and that might be another thing that kind of plant, with that level of sophistication, maybe that final 20% might be to look at some kind of battery storage and the arbitrage opportunities that might offer you in markets, and that's something that we could model for you. And maybe it's worth an extra $100,000, maybe it's worth more, but we could look at the sizing of the battery, the payback on the battery, and the benefits that it might deliver you in what is already sounds like a very sophisticated system.
All right, one final question, and then we'll wrap it up. What factors are used to determine battery capacity? The example they gave was a process that consumes a peak of 34 megawatts per hour.
Yeah, so that's a really good question, and I could spend days answering it. So we did a lot of work in the early days of the UK battery market 3 years ago, maybe 3.5 years ago. So I spent a number of months of my time, and I'll never get back, trawling the streets of London, looking at various different types of battery models and battery financing models. It's really dictated by two things, and that's the use case of the battery on site, and the markets and the requirements of the market that it's going to operate in. So if you take two extreme examples, you look at California, there's a proliferation of sort of 4 to 6 hour batteries, and you're looking at batteries which are effectively modeled on very long duration energy cost avoidance, and in the energy markets themselves. And then you go into PJM and you're looking at historically 15-minute batteries, more recently sort of 30-minute batteries, but I was going to say charged with, but that would be a pun too far, but basically tasked with almost pure participation in the frequency response markets for the ancillary services market. So how you're going to monetize the battery in market is perhaps the most critical factor, and then you overlay that with the use case on site. So what do you need the battery for on site? Do you need the battery at all, or are you just going to use the connection point to earn some money in ancillary services? If you need the battery on site, do you need it for those really long duration peak avoidance? Are you looking at using it for 2 or 3 hours? If you're in Texas, you don't need it for that long. You can get away with a 2-hour battery, maybe even 1.5-hour battery. But what is the use case on site? Do you have existing resilience issues? In other words, are you trying to shoehorn a battery into being a backup generator as well as a battery storage system? What do the energy markets look like? Do you have 1-hour peaks, 2-hour peaks? So they're perhaps the most defining factors of capacity for the battery. And then in terms of sizing, you're looking at, again, is it just going to be behind site load, or are you going to connect that and have the ability to inject back into the system as well as charge from into the network as well as charge from the network? But if you're looking at a pure behind the meter battery, we historically have sized batteries on the 95th percentile of consumption, so not quite on base load, but we're looking at periods of time when you're going to have 95% of your peak load available, which means that battery is going to be 95% of the time is going to be able to fully discharge to provide services to market. Otherwise, if you size a battery for peak, there's going to be a significant number of hours of the year, maybe even of the day, when it's not going to be able to fully discharge. So you're only going to be able to utilize a percentage of the capacity of the battery. And that's a very, very quick answer. Unfortunately, too long for going over time, but that's a very quick answer in terms of how we might size a battery on site. We'd ask you lots of intelligent questions. We do lots of modeling on your data, and we've come up with something which was optimized to cost you the least and make you the most.
Okay, well, that is the time that we have today. For those of you who maybe still had some questions, or we didn't quite get to your question yet, we'll pass them along to Wayne and Aidan, and I'll send along with the email with the link to the recorded webinar. I'll send along some contact information for you too, so that you can reach out to Grid Beyond if you've got some more questions as well. So
absolutely, we'd be delighted to talk to you after this. Thank you.
Wayne and Aidan, thank you so much for joining us and for sharing your information.
Shannon, thank you for organising. Really appreciate the opportunity, and enjoy your afternoon/morning, everybody.
Bye all.
Thanks, guys. Bye-bye.
Bye-bye.